What's up, everyone? Welcome to Ask a Chemist. Today, we're going to be working example problems on SN2 reactions. Let's get started. Our first problem asks us to draw the product obtained from the SN2 reaction of 2-iodobutane and methoxide ion. The first step that we want to follow is to identify the nucleophile and the electrophile. Our nucleophile is going to be the species that either has a negative charge on it or is electronegative. In this case, it's methoxide ion. It's an ion, so we know that this has a negative charge on it. Dead giveaway. That leaves 2-iodobutane as our electrophile. And I'm going to circle this in a different color so that it's obvious. Okay, so we've identified our nucleophile and our electrophile. The next step is to draw the product. It may be easier for you to draw out the Lewis structure of your reactants so that you'll be able to better visualize what the product would look like. So 2-iodobutane, you have a 4-carbon chain, and the iodine group is bonded to your second carbon. Methoxide ion has a negative charge. Okay, and so now we can draw a product. Now to draw the product, we have to recognize that this iodine, this group is going to be replaced with the methoxide. That's all that's happening. And so this is our final product. Final answer is going to be 2-methoxybutane. We also have a side product of iodide, but again, it's inorganic, and so we're only focusing on the organic compounds. Our last step is to check to make sure the stereochemistry is correct. Now, in this problem, the stereochemistry of our starting material was not specified. So we don't know if this is R, S, or a mixture of R and S. So because of that, we can't really specify the stereochemistry of the product. So 2-methoxybutane will just suffice as our final answer. Let's do another example. Draw the product obtained from the SN2 reaction of S2-bromohexane and hydroxide ion. Again, the first step is to identify the nucleophile and the electrophile. In this case, our charged species is hydroxide ion, so that will be our nucleophile. And that will leave S2-bromohexane as our electrophile. It may be easier to draw the Lewis structure of your reactants in this problem so that you can visualize the stereochemistry. Our stereochemistry is S. So let's start by drawing hexane. That's hexane, and then we know that the bromo group, or bromine, is bonded to carbon number 2. And I'm going to arbitrarily choose to have the bromine coming out at me. If I do that, that means that the hydrogen that's also bonded to this carbon is coming away from me. So let's go ahead and see if we can figure out what stereochemistry that gives us. Our heaviest group is bromine, so we're going to label the bromine as 1. Our second heaviest group is this butyl chain here, that's 2. Our third heaviest group is the methyl, so that's 3. And obviously hydrogen is 4. And if we go from 1 to 2 to 3, we're going clockwise. And because the bromine is coming out towards the plane of the page, this leaves us with R, the R configuration. So if this is R, in order to make this S, we need to have the bromine facing away from us. So let's go ahead and do that. Let's change this up really quickly. We have our bromine facing away from us. And then we have our hydrogen facing towards us. So now we have the S conformer. The second reactant is hydroxide. And we know that the atom or the group that is being substituted is the bromine. So let's circle that. Bromine is being substituted for hydroxide. So we draw a hexane for our final product. And at carbon number 2, we're going to put a hydroxy group. And because in SN2 reactions, you have inversion of configuration, instead of coming away from the plane of the page, this is going to be coming towards us. And then the hydrogen will be away from the plane of the page. Our final step is to check to make sure that the stereochemistry is correct. So to do that, let's go through our numbering system again. We know that the hydroxy group will be our largest group, or this is our major group. The butyl group is our second major group. The methyl group is our third major group, and then that leaves hydrogen as 4. If we go from 1 to 2 to 3, we're going clockwise. Because the hydroxy is coming out towards us, that's going to be R. And that's what we're looking for. We're looking for the R product. Okay? So our final answer is going to be R2 hydroxyhexane. All right, let's do one more problem. Draw the substitution product formed by the following SN2 reaction: cis-1-chloro-4-ethylcyclopentane and hydroxide ion. So again, we want to identify the nucleophile and the electrophile. Our nucleophile is hydroxide ion. And our electrophile is cis-1-chloro-4-ethylcyclopentane. This is our electrophile. All right, so now we draw the product. If you don't want to have to draw the Lewis structure of your reactant out, that's no problem at all. An easy way to approach this is to break this down. Start by looking at the configuration. This tells you that the reactant is cis, okay? If the reactant is cis, that means your product will need to be trans, because in SN2, you get inversion of configuration. Then our leaving group is the chloro group. This is going to be replaced by hydroxide. So we're going to have trans 1-hydroxy, and then everything else stays the same. 4-ethylcyclopentane. So this is our final product. Very simple. Now, if you're not here yet and you have to draw out the Lewis structure of your starting materials, that's perfectly fine. Let's go ahead and do that. We have a cyclopentane. This is our base. Doesn't matter which carbon we put the chlorine group on. And I'm going to have this chlorine group coming towards us. And then we put the ethyl group 4 carbons away, and that also has to be coming towards us because it's cis. This is reacting with hydroxide. And this is going to give us an alcohol as our final product. This alcohol is going to be cis because of inversion of configuration. So instead of coming towards us, we draw the alcohol group coming away from us. The ethyl group, the configuration for the ethyl does not change, it stays the same. And this is our final product. Trans 1-hydroxy 4-ethylcyclopentane. We check to make sure that the stereochemistry is correct. This one is pretty simple. We know that we started off with a product that was cis. We know that it's cis because this group and this group, they're both coming towards us, they're facing towards us, or coming out of the plane of the page. And so our final product has to be trans, and that's what we see. We have our hydroxyl group pointing away from the plane of the page, or away from us, and we have our ethyl group pointing towards us. That's trans. So We did it correctly. Thanks for tuning in today. I hope you found these problems to be helpful. Don't forget to subscribe, like, and share the video. Leave your questions and comments down below or send them to Amakemist. I'll see you next time.